Hello, everybody. Thank you for joining us today. I'm excited to be here with our Director of Science, resident Giant Sequoia expert, and fire ecologist, Dr. Kristen Shive, who will be speaking about a topic that has certainly been top of mind for all of us this year, fire in the redwood forest. It was a tough fire season and one that put our hope to the test amid all of the rest of the crises we've been facing together this year. And first, I want to say that our hearts go out to our community members who have been directly impacted by these fires. Many have lost homes and livelihoods, and we at the League are deeply sympathetic to the tragedies that so many have had to endure. I also want to express gratitude for the heroic work of our first responders and other emergency workers. In addition to the terrible losses many of us throughout California suffered through the weeks and weeks of oppressive smoke, all while sheltering in place. It has not been easy, but I can say that for me, like I'm sure for many of you, the redwoods have been a source of resilience. Coast redwood and giant sequoia are both fire adapted and fire resilient. But while our iconic forests have bounced back again and again over millennium, these fires are different. Our climate today is different. Our forests are different, and our responses need to be different. Today, we will share the latest about two recent Save the Redwoods League acquisitions, Alder Creek and Cascade Creek, with both burned this summer. Kristen will share a more substantial update about the fire impacts at those two critical properties, and I'll offer some thoughts about how fires have impacted not just our properties, but also our commitment to our conservation vision. As you may know, because of the generous support of many of you on this Zoom, we closed just yesterday on the purchase of Cascade Creek, 564 acres, including over 100 acres of old growth redwood forest, wedged between Big Basin and Año Nuevo state parks. And less than a year ago, we acquired Alder Creek, the largest unprotected giant sequoia grove in the world, and inholding in the Giant Sequoia National Monument. Both properties were impacted by the fires this fall. The CZU lightning fire moved through Cascade Creek and over 80,000 acres of coast redwood forest. And then a month later, the Castle Fire burned through numerous groves of ancient sequoia, including Alder Creek. I've had the opportunity to visit Cascade Creek since the fire, and what I've seen was both shocking and hopeful. A burned over forest floor with ridge lines completely denuded of cover, and the ground thick with ash and charred soil. And then within just weeks, sprouts of green were emerging from the black. Fern and sorrel on the forest floor, manzanita pushing through the ash, frogs in the deeper pools of the stream, and redwood sprouts everywhere. Up and down the scorched trunks, along charred leafless branches in the ground, and at the base of the blackened trunks, in huge shrubs of green, the coast redwoods are bouncing back, even in second growth forests that have had the chance to regain their natural resilience. But for all the extraordinary resilience reflected in the coast redwood forest, the giant sequoia groves suffered extraordinary and irreversible losses, as many of you may have seen in the New York Times feature just this morning. And as Kristen will share, while much property experienced low to moderate intensity fire, many sequoia on Alder and in other nearby groves were killed in the fire. Despite their thick bark and millennia of fire resilience, they were no match for the high density of fuels on the forest as a result of generations of fire suppression, or for the climate-driven, dry, hot winds that blew through at 60 miles per hour. Indeed, the fires of 2020 have told a tale of two forests. As the coast redwood forest response to the fire has cemented its critical value as a resource in the fight against climate change, the Sierra fires have drawn global attention to a new reality that giant sequoia are at risk of becoming victims of climate change. And in both cases, our role in that tale is to be better stewards, to accelerate the pace and scale of our conservation and restoration, to restore the natural function of these critical landscapes and ensure their resilience into the future. And today, to provide the scientific foundation to inform that critical work, we are so fortunate to have Dr. Kristen Shive as the League's Director of Science. I invite her now to share more about modern fires in ancient forests.
Thank you so much, Sam, and thanks to everybody for tuning in. I'm really excited to share a bit more about this year's fire season, what's been going on in both of our forests and both ranges, because the stories really are pretty different. It really is a tale of two forests. So hopefully by now you can all see my screen. Sam, let me know if it's not popping up for everybody. And, you know, as Sam mentioned, I'm going to talk about fire effects on the forest. And I want to just pause again, as Sam did, to acknowledge that there's a real human toll to these fires. A lot of people have lost homes. We've lost lives. There's been infrastructure losses. And so what I'm going to focus on today, when I say anytime that fire is good, or I'm talking about the benefits of fire, it's really specifically in regards to the forests themselves. And I just want to be clear about that at the outset, because of course our hearts do go out to where those losses occurred. And of course, there were some negative consequences on the ecosystems, as Sam's already mentioned. So with that, I'm going to jump in, and I'm going to start right off here with a graph, but don't worry, there won't be a ton of these. What you're looking at here is wildfire trends in California since 1950. And this graph shows through last year, 2019. And the dates there on the bottom, that shows you the x-axis, there's your through time. On the y-axis is the number of acres burned. And what you can see is what we already, I think, know intuitively, which is that we are in fact getting more and more fire. We're getting bigger fire seasons with more acres burned through time. There's variability always. You know, 2 years ago, we hit that 1.6 million acre record, but then last year was a pretty light fire year, considering, at about 280,000 acres. This year, we're not yet done. There will be more acres added to the total, but of course, we're approaching 4.5 million acres. And so this year truly is a game changer. And when you look at it relative to these past fire years that we've known, it really kind of hits you just how big and different this year was. But you know, when we look back in the past, what you see now, if you go before 1950, I just inserted what the historic average annual area burned we think was. Scott Stevens and some others did a bunch of research to come up with this estimate. And of course, it also varied every year. But the point is, there used to be considerable amount of fire on the landscape. And this year, you know, we're actually getting close to approaching what would have been the historic normal quote unquote fire regime. But of course, a lot of things have changed since then. And so that is not all a good thing in terms of restoring fire to the landscape. And specifically, as we've touched on, you have more people and infrastructure in wildland areas, which leads to more negative consequences for people, but it also can complicate how we manage fires in forests. The changing climate, of course, is another big one that we have to contend with. And that, with some past forest management, is really influencing our fire severity. And I'm going to talk more about those in sort of the big picture context, as well as in both ranges. So today, I'm going to walk through some fire ecology basics and take you through Fire Ecology 101, so you can all be fire ecologists. And then tell that tale of two forests in both Giant Sequoia and Coast Redwood, because when it comes to fire, they really are very different. And then I'll wrap up by talking about some ideas about how we can restore fire resilience going forward. Okay, so one of the most basic ideas in fire ecology is that of a historic fire regime. And what that describes is an ecosystem's historic or pre-colonial fire exclusion, their historic relationship with fire. And we focus on that historic fire regime and understanding it, not because we want to try to go back to that exactly, but it gives us a lot of clues about what ecosystems are adapted to and about their sort of evolutionary history and evolutionary relationships with fire. And so in order to understand if modern fires are having positive or negative consequences, we really need to understand what is sort of quote unquote normal for that ecosystem. So the concept of a fire regime includes a lot of things: the spatial complexity of how the fires burn, how big did they get, what time of year did they burn. In California, of course, it's summer and fall, but here in Florida, it might be winter. how frequently did they burn, and how severely. And really, these two are by far, I think, the most important to understand what's happening in our forests today. And I'll start first by describing fire severity the way that we define it as fire ecologists. There's three main classes. There's a ton more variability in here. I'm just giving you the really broken down snapshot version. And I think the most important thing to think about are these three classes, which are characterized by low. So that's less than 25% mortality of the overstory trees if you're in a forest. So that would be like a fire you see here, where it's burning on the forest floor, consuming a lot of the dead woody debris, as well as the small trees and shrubs, and occasionally killing some of the overstory. Moderate is a really pretty big catch-all category. It's 25 to 90% mortality. Here, the fire is able to transition up into the crowns and take out larger groups of trees. And then we have high severity, and that's generally greater than 90% mortality, or at least greater than 90% of the trees will have suffered total crown loss. In many areas, it's 100%, and this is where we're seeing really big changes on the landscape. So what controls fire severity? So this is what we call the fire behavior triangle, and this is one of the first things you learn if you're going to become a wildland firefighter in your first season. And the three key pieces are topography, weather, and fuels. Topography, so that's the terrain. Steeper slopes tend to burn hotter, but that doesn't really vary through time. Of course, it does in space. We have mountainous terrain and flat terrain. But in general, you can think of each of these factors. You increase any one of them, you're going to get increasing fire severity. So like I said, steeper slopes, you tend to get hotter and more severe fires. In addition, with weather, we all know that when we have hotter, drier conditions, we start to get a lot more fire, and that increases the fire severity as well as just fire occurrence. It's a little bit harder. Not only will more fires ignite, but it's harder for firefighters to sort of get those in check, and so more of them grow to a large size and then potentially burn severely. And this is where climate change really comes in. So what we're seeing here, this graph, I'll walk you through it. In red, that is the count of wildfires, and that corresponds to the y-axis on the left side of the graph. On the x-axis, you have time, starting in 1970 through 2012. And the red represents fires over 1,000 acres. And you can see that through time, we're getting more and more fires. I've already shown you that data, of course. But overlaid on that is temperature. And that's what you see in the black line. And that corresponds actually to the y-axis on the right side of the graph. The main thing to pick up here is that when the wildfires are spiking, so is that spring and summer temperature. And what I think is really interesting is Tony Westerling and others who worked on this, these analyses, what they found was that precipitation from the last winter was important, but not nearly as important as the spring and summer temperatures. And that's because of the effect that it has on drying out our fuels. We're also getting, with climate change, more severe wind events, as I'm sure you all know. But one really crucial trend is that we've always had strong winds in the fall in Northern California, but now because fire seasons are longer, it's hotter and drier longer, those extreme wind events are now occurring at times where it's pretty hot and dry. And so all of these are sort of coalescing to increase how much fire we're getting, and in some cases, the severity. So now let's go to the third leg of the triangle, which is fuels. And how do we define fuels? Really, it's anything that can burn. So that is dead wood and live trees or other plants. Here you see what we call surface fuels. These are one of the most important for how fires spread and grow. It's one of the things fire ecologists think about a lot. So that's just all the dead woody debris, pine needles, dead logs, etc., on the forest floor. We also think a lot about ladder fuels. So those are the small trees and shrubs that can grow in and help enable a transition from a surface fire into a crown fire. And I'm going to talk a lot more about this later, but by excluding fire in many forested ecosystems, we've really increased this leg of the triangle dramatically. And this is where, when you hear people talk about why forest management matters in our fire problem, it's for this reason. And so I want to pause here for a second and just note there's a lot of debate I see sometimes in the media that whether our fire problem is a climate change problem or a forest management and fuels problem. And I just want to be abundantly clear that it is both in many systems. And we have to just be sure not to confuse or not to try to push it into either one. I feel like we're in a very polarized time and we always want to kind of go for black and white, but we have two contributing factors that we need to contend with. Okay, so now with that understanding of fire severity, we can link that back to how we understand historic fire regimes and then how fire frequency and severity are related. Because of course, if you're having that regular fire, in this example, this is a mixed conifer forest in the Sierra Nevada, it probably burned every 10 to 20 years. That means that there's just not a lot of time between fires for a lot of fuels to accumulate. And so the relationship there is high frequency means that historically you probably had mostly low severity fire, though probably some moderate. I want to be clear here though, I mean, I think it's probably obvious already, I'm leading up to how like the increase in fuels has increased severity and that can be problematic. But I do think it's important to note that for some ecosystems, high severity is normal and even good for them. A good example is chaparral, the shrubby ecosystems on coastal California. They often have historically had very long fire return intervals. They had a lot of time to accumulate fuels, not much lightning on the coast. And when they finally did burn, they burned pretty hot and they're well adapted to that. So this just sort of gets back to the reason I introduced the whole concept of the fire regime is that you need to understand where you're coming from and your evolutionary history and the adaptations to know what is quote unquote good or bad. So with that, I want to start delving into the species and the forests themselves, starting with wildfire and giant sequoia. We're going to start really big picture here and talk about their whole range. All of the world's giant sequoia are restricted to the western slope of the Sierra Nevada. What you see in this map here is there is the brown shows the mixed conifer forests, and the blue shows the 73 distinct groves of giant sequoia. And that is a really small area. It covers about 1/10 the size of LA or New York City. So we're talking, again, the world's ancient giant sequoia are hemmed in a pretty small area. We don't have a ton left. In addition, up to roughly 1/3 of the range was logged at the turn of the last century. And so, you know, in terms of old growth, it's an even smaller subset of that. In terms of the historic fire regime for giant sequoia, it was a very high frequency fire, burning roughly every 10 years. That's what we call the fire return interval. And these fires were started by either lightning, or of which there's a ton in the Sierra, or intentional burning by indigenous people who are tending their landscapes. The way we know how frequent the fires were is to look at fire scars and tree rings, and that's what you're looking at here. Each year, a tree puts on an annual growth ring. Dendrochronologists have figured out some amazing ways to date those. And then you can see those black marks where the arrows are pointing, that's where a fire has scarred the tree. And so we can go back, get exact dates that fires burned, and then get those sort of intervals. And you take a ton of samples so that you're, getting a good idea of what the variability is out there. Sequoias are particularly exciting because their rings are really clear and they record fire scars really well. And so we have a very reliable record of fire history that goes back well over 1,000 years in giant sequoia. I think it might be the oldest one that we have globally. And so going back yet again to that frequency and severity relationships, this necessarily means that when fires did burn, that they burned at generally lower severity. And this is a good example here. This is actually a modern prescribed burn, of course, in Mariposa Grove at Yosemite National Park. But I think the forest structure is pretty close to what it may have looked like. There's not a lot of fuel on the forest floor, and overall the forest is pretty open. And so those frequent fires could limit the future, the severity of the next fire. And of course, the species itself is really well adapted to that. It has this incredibly thick bark. The thickest are up to 4 feet in some specimens. And they also have these incredibly tall crowns, which helps them escape the heat of a surface fire. I do want to note, though, that smaller patches of high severity are a part of the historic fire regime. Anywhere from half an acre to maybe even a few acres was probably really important for regeneration. First of all, when the fire comes through and burns a hotter pocket, it really opens up the canopy, and by killing some of the trees and the other shrubs in the areas, it brings a lot of sunlight to the forest floor, as you see here. It also opens up the cones. So you can see these green cones will stay in a giant sequoia crown for 20 years or more, and there are thousands of them. When a fire comes through, the heat can open up the cone, and you can see those cracks there where it dried out and opened up, and it disperses just thousands and thousands of seeds. And it does it at just the right time. You know, that is an evolutionary adaptation where the seeds are cued to adapt in the conditions that are best for them. And that is this bare mineral soil, the sunlight hitting the forest floor, and that's why there's tons of them that come back in these conditions. So they really tend to regenerate pretty well after severe fire. So what has changed in the modern era? It really started over 100 years ago with fire exclusion. This is a picture, again, from Mariposa Grove in Yosemite National Park, and it's called the Confederate Group. You can see that the forest is pretty open around these monarch or old growth giant sequoia. This picture was then taken in 1970. And you can see there's been a massive change in the character of the forest. And that is going to have a significant impact on how a forest will burn after all that fuel accumulation, and the potential for high severity is much, much greater. So what has this meant for giant sequoia in recent history? This again is a graph of area burned by acres burned on the y-axis, and then dates on the x-axis starting in 1910 to 2020. And what you can see is that in the last 5 years, we have had a dramatic change in how much fire we're seeing in the giant sequoia groves. And unfortunately, that tends to correspond with increases in fire severity. This map here shows all the fires since 2015. There were 4 of them. And after, the first fire in 2015 that was large and affected a lot of sequoia groves, that's shown here in orange, burned partly in Sequoia Kings Canyon National Park and partly in Giant Sequoia National Monument. And we started hearing some anecdotal reports that more monarchs were killed than expected, because honestly, before, given their extreme fire resilience traits, most scientists and land managers thought, yeah, sure, we would lose some, but they're probably mostly going to be okay. And we started hearing these reports that it may be a little bit more severe impact to the giant sequoia than we had thought. And so after the 2017 wildfires, which, you can see in purple, one is the one up to the north, just south of Yosemite. That was the railroad fire, burned into Alder Grove. The other is down south in Giant Sequoia National Monument. Let me get my pointer, that might help. There we go. Down here in Giant Sequoia National Monument, and that burned through the Black Mountain Grove. And what we found was really shocking. We worked with the US Forest Service to initiate a research study that we just wrapped up this year and we'll be publishing on, that looked at not only what trees were immediately killed by the fire, but what trees were also killed which trees died after a couple years, because sometimes there's delayed mortality. And at Black Mountain Grove, we found 54 dead monarchs. At Alder Grove, there were 33 dead monarchs, which in that small grove was a third of all of the old growth. And what was really, the thing is that this was shocking when it happened. We kind of couldn't believe how many dead trees we found, because remember, each one of these, they were at least 6 feet in diameter, and the largest of them would have lived through hundreds of those regular fires. And then to succumb like this, just very shocking. Of course, 2020 has sadly blown these impacts out of the water. So what I want to show you here is a severity map. So all of the colored area is the area of the SQF complex, or Castle Fire. And the colors correspond to the fire severity that we talked about earlier. The dark green is unburned or low severity. This data comes from remote sensing. So satellites take a pre-fire image and a post-fire image and then difference them. And if it's dark green, it means that maybe it burned so light that the satellite couldn't even detect it, or it's completely unburned. The lighter green is low severity, orange is moderate, and then red, the one we're most concerned about in Giant Sequoia for the loss of monarchs, is in high severity. What you'll also see on this map then are the polygons of the Giant Sequoia groves. And you'll see that it burned through acres, is far and away more Giant Sequoia than has burned since we've been keeping records. And what is probably most astonishing here, of course, is that it primarily burned, or it didn't primarily, excuse me, but we had nearly 40% of that area burned at high severity. I want to point out here a couple things before I move on. The white stars that you see, one is here in Freeman Creek, and then one is up here in Mountain Home, which is state demonstration forest. Those are areas where we have a Redwoods and Climate Change Initiative plot. The Redwoods and Climate Change Initiative is a program that the League has been running to try and understand climate effects on these amazing trees. And we have in both ranges plots that are about 2.5 acres in size, where we've measured every single tree and mapped it, including the logs on the forest floor. So we're going to go measure these post-fire, and I think we should be able to tell a pretty good story about what happened out there. The other thing I'd like to then talk about are some effects in specific areas. So some of you who've been with us for a while might remember about 10 years ago, we protected Dillonwood Grove. That's this piece. This is actually, we transferred that to Sequoia Kings Canyon National Park, which includes this area up here as well. Sorry, that's part of the park. That's not part of where we transferred. We really concentrated our work on the Dillowing Grove that was still in private hands. It's mostly second growth, and you can see it mostly burned at lower severity. So pretty probably good effects there, because recall, lower severity can almost be restorative as they would have experienced historically. The other thing I want to point out really more for later is that down here is Red Hill. That grove, we purchased 160-acre inholding in a couple of years ago. We're going to be transferring it to Giant Sequoia National Monument, who owns the bulk of this land in here. And we'll be transferring it in 2022, but before we do, we're planning to do a prescribed burn to help restore fire resilience, and I'll talk more about that later. And then lastly, what I want to zoom in on here is Alder Creek Grove. So hopefully, many of you know, and Sam already discussed how we purchased a really incredible property that had 430 acres of old growth on it, which is a subset of the larger Alder Creek Grove. And I want to talk specifically, use this as a sort of a test case to just talk about what happened, what the impacts look like on the ground. And so what you see here, it's another severity map just of our property, and that's in the darker black line. That's our property line here. And then the blue line, this is the grove area on our property. And so within our property where we had surveys, we were looking here and here for significant impacts to monarchs. And what we're really lucky is that within our property, most of the monarchs survived. You can see that most of them burned at lower severities, but we did have those severe impacts. And I want to just show you some visuals to show you what that looks like. Here, this little symbol with a tree is the stag tree, which is the 5th largest tree in the world. And recall that giant sequoia are really the most massive trees on Earth. Coast redwoods are the tallest, and I like to say that giant sequoia are the chubbiest. And that tree was in a low severity area, and it did great. There were really no direct fire impacts to the tree. We did ask firefighters to take extra special care of it, but overall the whole area didn't really burn or burned very lightly, so we really lucked out. The one thing we will have to do, there was already erosion problems from over-visitation, which the League was planning to address by putting some more infrastructure or something there to help guide visitation so that there's not quite as much erosion at the base of the tree on the fragile roots. But the firefighters also dug some hand line as a precaution around there. And you can see in this picture, if you look down at the bottom, there's these exposed roots, and that is going to need some addressing. And we will be working on that. For the winter, we put some mulch on it. That's our forester there. And we have it sort of ready for the winter, but in the long run, we're going to have to do a little more rehab. But here you can see just the variability of these fire effects in the center of the property, which is that lower severity, some areas that didn't burn at all. And then here, I want to show you this video. It's a little bit hard to watch for me, at least. And you can see this is at the top of the ridge where there are a bunch of dead monarchs. In total, we counted at least 80. Our surveys are not complete for safety reasons. We weren't able to do complete surveys, but we will take a look next year. But it's really powerful to see these ancient trees that lived through so many fires die. And so what comes next in that area? Well, we're probably going to get a ton of seedlings that are going to come back naturally. This is from the Black Mountain Grove just 2 years after. These are all sequoia seedlings. They're coming back very vigorously. So from the standpoint of the species, there's not a ton of work to be done. We might want to do some work on fuels or think about some of the other species and how they were affected. But because of those cones that open in the heat of the fire, we're in pretty good shape. Shifting over to coast redwood. So this is the distribution of coast redwood. It goes all the way from southern Oregon down into Big Sur. And highlighted on the map there is Cascade Creek with the coast redwood range in brown. It covers about 1.6 million acres. And I think it's really important to note, though, that only 5% of the old growth remains. All of the rest was logged, much of it a long time ago, and some of it is currently still in industrial management. So if we go first to that historic fire regime, in particularly more recent centuries, a lot of the coast redwood forests, particularly in the warmer and drier south, which burned this year, had pretty frequent low to moderate severity fires. And those came primarily from indigenous burning. Unlike the Sierra Nevada, lightning is pretty infrequent on the coast. And so to have the frequent fires that we've seen in the fire scar record, and of course, listening to oral traditions by indigenous people, we know that there was just a ton of indigenous burning. They usually focused on grasslands and oak woodlands that were adjacent to redwood forests, and then the fire would burn through. But nonetheless, in tending the landscape, really the native people helped to keep the fuel loads low. And of course, similar to giant sequoia, they also have very thick bark, tall canopies, and here you can also see evidence of those past fire scars. But what I think is most interesting, I tend to think of coast redwoods as kind of weirdos, to be honest, because they have that classic adaptations that we talked about to the lower severity fire regimes, but they also have a history and adaptations to higher severity fire regimes. So certainly when we think over really long time scales, because lightning is so infrequent, that means during certain periods of time or certain locations where there wasn't a lot of indigenous burning, there was more time between fire, more time for fuels to accumulate. And so when fires did burn during a hot, dry lightning event, we would get severe fire. And what's super remarkable is that redwoods, of course, have evolved to survive those fires. In here, you can see they can sprout from their base, but what to me is so remarkable, that's why I have it as my backdrop, is that they can also sprout from their trunks. And there just aren't a lot of conifers in California that can do that. It's a pretty exceptional adaptation to fire. So they can take complete crown loss, what would show up as red as high severity in those remote sensing maps that are just looking at the difference in greenness pre and post fire. But the difference is here, the redwoods are going to bounce back. So the effect of fire exclusion then is sort of, there's definitely more fuels than we would have had under an indigenous fire regime, but maybe not as different as some periods in their long and storied history. Potentially more problematic, though, from a fuels perspective, is the young, dense forests that are recovering from past forest management practices. They have that high density could potentially increase fire behavior. So zooming in on the 2020 wildfires, that they are all shown here, the ones that impacted the coast redwood range. It included about 81,000 acres burned. Roughly 10,000 of that was old growth. And I want to really focus in on the CZU complex. Sorry, there, I want to show you. That's this one here in Santa Cruz. And you can see there's a significant amount of high severity that burned throughout here. Again, we're looking at the same color ramp for the severity classes. Highlighted on the map here is Big Basin, which I'm going to talk a little bit more about, outlined in black. And then Cascade Creek, which we just closed on and purchased yesterday. Shout out to the land protection team, shown in purple. And so just talking specifically for a moment about Big Basin, what you're seeing here in that dark shaded area, that's where the actual old growth in Big Basin occurs. And you can see it all burned, much of it at high severity. 70% of the entire park burned at high severity, but of course we know that the redwoods are going to, by and large, sprout back to life, which is exciting. I mean, these pictures were taken just a couple of weeks ago when I visited the park. And so the potential for redwood recovery is strong. But there are some drawbacks to getting this high severity. You know, we only have 5% of the old growth left. And so we have to think about, is this the type of fire that we want those areas to endure? And then what are the implications of that? This little guy is the marbled murrelet, an endangered bird that can only nest in old growth forests. And in fact, it tends to prefer the Douglas firs. In most coast redwood forests, particularly in Big Basin, Douglas fir is a tree that is another important component of the forest, and they don't sprout back. So when those are lost, that's a loss to that old growth system. In addition, these guys, they don't just need the branches to nest on, but they also need a lot of cover for protection. And so it's going to take a while for those crowns to grow back to where these guys feel safe nesting in those areas again. It's unclear what the impact of these fires is going to be on this endangered bird species, but when you have so little old growth left and there's so much habitat fragmentation, it's really important that we think about what kind of fire we want in those areas. Even if the coast redwoods can handle it, there are other negative consequences. So then I just wanted to talk really quick about Cascade Creek. And this is, again, such a triumph that we just purchased this amazing patch of ground. The darker polygon area under the fire severity map, again, that is the old growth. Up to 40% of the property, though, did burn at high severity. And so the impacts were pretty significant. And I'm going to show you a video. It works. Right now, we're coming up that drainage in the middle that you saw in the last map. And that's where a lot of the old growth is, and it burned at lower severity. However, there is old growth as we're looking up drainage here. And you can see the more severe burning at the top of the drainage. There is old growth up there that did burn. A couple things that I think are sort of interesting is like the way we think about the other forests and how hot it burned. Where you see the brown needles, those trees were killed by the heat of a surface fire. Where you see the blackened twigs, those areas had total crown loss. And hopefully you saw a little bit in there, places where there's a little bit of green popping back. So things are already starting to regenerate at Cascade and really throughout these fire areas. And so in general, we don't think it's going to need a ton of work to recover or a ton of help, but we will likely track it, of course, to see. Okay, so now I want to shift gears. Now that we understand the impacts, we understand what we think is potentially beneficial or not beneficial about these fires. You know, one thing I think I glossed over, but even though 37% of the Castle Fire / SQF complex burned at high severity, and that means a ton of monarch losses or old growth, monarch is what we call old growth. Even with that, a lot of those areas did burn at low severity, and that probably did some good work cleaning out the fuels. So as we think about how these all worked, I think we need to think about restoring fire resilience on the big scale. And what people tend to think of first is, what should we do for these burned forests? I've had so many people ask me, what can they do? Can they come help plant trees? And honestly, specifically for these species, we probably don't need to do much. The coast redwoods will sprout back to life. The giant sequoia are incredibly successful at regenerating after hot fires. And so for those species, we're probably pretty good. It is possible that there's some other work that might need to be done, particularly in the Sierra, in part because of some of the other species that are there. But by and large, a lot of what we need here is time. What I really want to focus on, and I think is the lesson to be learned from the 2020 wildfires, is that it's the unburned forests that really need our help. This picture comes from our property in Red Hill Grove, that one that I pointed out on the map that we have 160-acre inholding on. And you can see this really is an incredibly fuel-loaded forest. And we're planning a prescribed burn for 60 acres that we were hoping to do this fall. Unfortunately, with all the fires, it just wasn't able to happen, but we will be working on doing that in the spring. And so when it comes to prescribed fire, I want to show you a video of what this looks like. This video was taken by Linnea Hardland, our forest fellow. And I want to just show you that controlled burns or prescribed fire, that's when we go out with drip torches, or managers do, and the league's down a couple now. We go out with drip torches and intentionally light the forest on fire. It's done under very controlled conditions, very narrow and specific sort of weather, weather windows that work. It can't be too hot. It has to be humid enough. You don't do it on windy days. But I think the main point is that these aren't scary roaring fires. It's just some fire to sort of clean up those surface fuels. They are, though, very hard to pull off because you do need that perfect weather. You have a range of temperatures and a range of humidities that are acceptable. You need to assemble like a ton of resources because anytime you do this, you need to have fire engines there. You need to have hand crews there just in case something does get out of control. Smoke is always an issue. And so they can be really hard to pull off, but they're extremely effective because mostly they can burn off those surface fuels that drive a lot of fire behavior. Ultimately, the biggest limitations to getting more of this done are funding and capacity. Our agencies are very cash strapped, and overall, they've lost the positions that they used to have to do a lot of this work. Another tool in our toolbox is mechanical thinning. And I just want to address and name here, I know for a lot of us who think about conservation and saving forests, talking about cutting trees feels a little bit uncomfortable. But cutting out those small ladder fuels with chainsaws is an important piece of the puzzle. The biggest benefits of doing this is that you're not limited by a weather window. You can do it just about any time of year, except if there's too much snow. It's lower risk. There's no risk of fire escaping your prescribed burn boundaries. And really, you can make a bigger change in the forest faster. The one negative, the downsides to it, though, is it's not taking care of the surface fuels, which is really, really important. You could also do chipping, which is another way that people then dispose of some of those trees that they cut. And then finally, you can pile burn some of those trees that you cut. But that is one of the other big limitations, is that you have all that biomass once you cut it, and what do you do with it? It's not worth much. It's not easy to go, you can't sell the logs. They're too small, they're too tiny, and you have to figure out something to do with them. And so that makes it really tricky. And overall, the treatment is much more expensive than prescribed fire. Collectively, I think the main thing we need to do is just think about using all the tools in the toolbox. And I always say, right tool, right place, right time. And there's times where mechanical thinning is going to be more appropriate, and there's times and places where prescribed fire is going to be more important. But the most important thing we can do is increase the amount of what I like to call good fire on the landscape. And that can be in the form of prescribed burning, or in the right places at the right times of year, allowing even lightning strikes to do their work. So I want to end here on a success story. I showed you this picture earlier, or this set of pictures, the Confederate group at Mariposa Grove in Yosemite. On the left, you see that 1890 really open forest. And then 80 years later, just how dense it was. Well, Yosemite, along with Sequoia Canyon, was really pioneering in realizing that these areas needed fire, not just to reduce the fuels, but so that they could regenerate. And so they started aggressively doing prescribed fire, and have been for the last 50 years. In the 1970s, they also started off with some mechanical thinning. And this is a picture from 2000. I need to go take another picture from this year just so that we can have a more up-to-date picture. But the point is that it works. We know that it works. And in Grant Grove, which is in Sequoia Kings Canyon, and burned in the 2015 rough fire. They had burned most of the grove, but a piece of it hadn't burned. And when that rough wildfire burned through, I mean, it was almost textbook. You had the areas that had been prescribed burned overall did pretty well, and you had really high survival of the ancient trees. And the areas that hadn't been prescribed burned, you had a much hotter fire with a lot of mortality. So we know this stuff works. We just have to do something about it. Lastly, and I just don't want this to go unsaid, you know, we think about forests and how we manage them. That's kind of what we do. But of course, climate change is a huge piece of what we need to do about this problem. And so that means as a globe, as a country, we need to reduce emissions in a major way. And we also need to take care of these forests because they are carbon storing powerhouses. They store more carbon than any other forest type on Earth. But they won't do that if they keep burning up. And so if we want to preserve these forests in the future, we're really going to have to work on how we take care of them. And so with that, I just wanted to say, acknowledge some of the help I got putting this together. I already mentioned Lene, our forest fellow, also on our science team, Sonia Morris did an incredible job with the maps. And there was tons of help, of course, all over the league in pulling off the actual webinar itself. And so with that, I think we can switch to questions.
Thank you so much, Kristen. That was fantastic. And this is Sam Hodder again. I'm going to be taking some of the many questions that have been entered into the Q&A panel and feed them into Kristen. And I want to assure everybody that we won't be able to get to all of them, and we'll do our best if you've left your contact information to work on some of the additional questions after the fact and send them along. But in the meantime, there are a number of questions that have come in about prescribed burning, trying to better understand the ratio between historic fires and fire acreage and the capacity of our stewardship team broadly to advance prescribed burns. Could you start with, Kristen, speaking to that disparity between what would be a typical natural fire regime versus what we've been able to burn via prescribed burn in recent years?
Yeah, great question, Sam. You know, as I said, historically, we are reaching close to 4.5 million acres, and I don't have at my fingertips how many acres we've been getting in prescribed burning. I think it's probably in the thousands annually. But it's nowhere near, even if it's tens of thousands, it's definitely nowhere near what we need to be doing. And the primary limitations there is capacity. We just don't have the funding and the staffing to be able to do that work. It's expensive. It takes a lot to take care of these forests. An example that I always like to point out is that, you know, I worked in Yosemite a couple times in my career. When I worked there in the early 2000s, we had 3 seasonal crews and 4 permanent staff that were dedicated just to doing these fuels projects. And fast forward, when I went back in 2016, there was 1 permanent staff and 1 short crew. And we just, and consequently, their prescribed acres went way down in terms of what they could do. They're an amazing staff, they're doing what they can, but we really need funding to pay the people to go out and do this work. And then lastly, I would say one way that could help us get it there is working on our workforce capacity, right? And there's been a lot of talk about that in California. And some ideas I've heard floated that I really like are the idea of a prescribed fire training center that not only trains up more people to be burn bosses and to be able to implement the work, but as they're getting trained, they're literally burning all over California. So I think the solutions are out there to catch up. We may never get to what we need, but I think we can significantly scale up if we invest in these forests.
That's great, Kristen. And you mentioned this a little bit in the presentation as well, but a number of questions have zeroed in on this. Can you speak to the balance of and different utility and different circumstances between prescribed burning and mechanical thinning?
Sure. Yeah, and so that I didn't have as much time with that as I'd hoped, but mechanical thinning is going in and, you know, I talked about surface fuels, the woody debris on the ground, and then the ladder fuels, the smaller trees that may have filled in, particularly in the Sierra Nevada, as a result of fire exclusion. And if you thin, you go in with chainsaws and you literally cut down those smaller trees and you remove them. Again, as I mentioned, there's a problem though. What do you do with all that biomass? You can't sell it. Nobody wants it. You can't, you know, use it for lumber. And eventually what people often do is just burn that in piles. Prescribed fire is is really quite different, and it takes a lot of luck and magic to pull off, I think sometimes, or at least a lot of hard work. And that's where fire trained professionals take drip torches or these tools to actively put fire on the landscape. And they're in very controlled ways. They do it under just the right conditions. But the big key there is that that will also burn up those surface fuels as well as some of the ladder fuels. They're just the big differences in how you might use one where have a lot to do with how close are you to homes, how much personnel do you have to do the burn? Sometimes you just don't have it and you think, well, at least we'll get it thinned. Really, to get to a very fire resilient state, both is actually the ticket. If you can thin and then burn, you're doing pretty good and you're going to make a real change in the fuels.
Great. Can you describe some of the recent prescribed burn activity that the League and our partners have been advancing?
Absolutely. I wish I could tap Anthony here, our stewardship manager, because he's been involved in a couple that I haven't. But we've already done one up in the North Coast, I know, near Stansbury Ranch, I believe, last year. And last year we also did our first one on League-held lands, and that was 20 acres at Beaver Creek, right next to Calaveras State Park. This year we're planning a couple more, again, up at Stansbury Ranch. And well, we were planning one at Red Hill, that 60 acres, but it's going to have to happen probably next year now. I have to tell you, it is a lot harder to pull off as a private landowner. I used to work for the National Park Service, and we had an army of engines and firefighters, not as many as we needed, but they were sort of there and on staff. But as a private landowner, it's definitely more challenging.
Yeah, and you've spoken to this as well, but there have been a number of comments about some of the impacts of prescribed burns, whether it be air quality or what have you. Can you speak to some of both the short and the medium term impacts of prescribed burning?
Sure. So in terms of the short-term impacts I think I'll take smoke first. You do put smoke in the air, and that's not pleasant. I admit it, I don't like breathing smoke, none of us do, but unfortunately, California is a fire-prone place. We can't avoid it. It's not a question of if it's gonna burn, but when. And so we have to decide how we want our smoke. And if we do prescribed fires, which can be smaller and planned at times where there's good smoke dispersal, we're going to have less smoke impacts than if we wait for things to burn very severely and smoking us out for months at a time. And so I think at the end of the day, there's no option that doesn't have smoke. We just have to decide how much we want. And in the long run, hopefully we get less. In terms of the impacts on fuels, the one thing we have to remember when you talk about long-term impacts is that you can do the prescribed burn and it's wonderful, but then 10 to 15 years later, you're gonna need to do another one. And that's the thing, is that we're gonna have to learn to live with fire because it's going to need to be a regular occurrence in the long run.
So there have been a lot of questions, Kristen, I gotta admit, about how people can get involved. People looking to have an impact and whether they want to participate in prescribed burns as volunteers or get into the kind of research work that is going to help inform our stewardship, or how to use their philanthropic dollars most effectively to try and address this challenge. Can you speak to some of that, how people can get involved and what you would say to young professionals or graduate students that want to help?
Yeah, I think specific for us, sort of, you mentioned philanthropic. Of course, we have our Forever Forest campaign and the Redwoods Parks Fund. And with that, all of that can help us with all of our work. I mentioned we were doing a Giant Sequoia research study. We're going to be initiating research studies on these 2020 wildfires so we can better understand them, their impacts, and what we can do different going forward. So of course, that's really important. But in broader terms, from if you are a young professional, I would say try to go out and get a job working for the Forest Service or the National Park Service, and try their seasonal jobs and get on a prescribed burn crew and learn some of those tools. And then even here at the League, we have a Forest Fellow program, which can help bring early career folks into the fold. So keep your eyes out for that. We might expand that in the future. But I think one of the big ones, of course, is just trying to keep your eyes out for legislation that you can tell your policymakers, yes, we want you to fund more of this work.
Excellent. So there was also a question about the coast redwood and but perhaps inspired by the pipe cleaner redwoods we see in your backdrop, and trying to understand how long it takes for old growth redwoods that are sprouting epicormically with the fuzzy green stems to really generate a crown canopy like what was there before.
I think we're looking at, at least a decade, if not decades, to get a full complex canopy that we used to have. So it's going to be a while in those really hot areas. Keep in mind though, in some areas, the trees did retain their branches and their branches are actually sprouting. So there, it's really maybe more a matter of years before they look like they used to.
Excellent. And then one question that I know you've been thinking a lot about in the giant sequoia, I'm sorry to be jumping around a little bit, but how have the bark beetles and what sort of research about the bark beetle has informed our understanding of how sequoias have responded to fire? Has there been an interaction there?
Yeah, great question. And I want to make sure to differentiate that the bark beetles that we all saw kill so many trees in the Sierra Nevada a few years ago during the massive drought, those are a specific kind of bark beetle that don't really touch the sequoia. It's called the Fleacinus beetle, is the one that will attack sequoia. And for years, it's always been around, but it's just never really been a problem because sequoia are so tough. In recent years, with drought-like conditions, we're finding that you add that with minor fire injury, even fires that can be really good at the wrong timing with drought might be causing more mortality. And honestly, we still are just figuring out this new and novel interaction. It also seems to only happen in very specific areas of the landscape, but the League has funded research to better understand what's happening with this beetle. And so hopefully in the next year or two, we will have a much better idea of the impacts.
Well, thank you so much, Kristen, for your awesome presentation. And I want to thank everybody for your thoughtful questions and the engaging dialogue in the chat. Again, we'll do what we can to respond to as many of these questions as possible. But as we're nearing the end of the hour, I just wanted to summarize a little bit, first of all, and thank everybody, of course, but then to acknowledge that this is really a wake-up call. The fires of 2020 have impacted the coast redwood and giant sequoia forests in fundamentally different ways, requiring substantially different conservation engagement, but to achieve consistent results. That is to restore and enhance the natural function and fire resilience of these extraordinary forests. We need healthy, resilient redwood forests, and we have to make that happen. In the coast redwoods, their resilience to this year's fires has reminded us how much we rely on the habitat connectivity, the carbon storage, the inspirational stability and beauty of these landscapes in a changing climate. We need to prevent further loss of coast redwood forest to development and to inappropriate forest management, and ensure that more of the forest is restored to a fire resilient maturity as a critical ingredient to building a broader resilience back into our coastal landscapes. In our centennial vision, we are committed to accelerating the pace and scale of our land conservation in the coast redwood forest and setting whole landscapes on a trajectory to be the old growth of the future. In the giant sequoia, the 2020 fires have proven once and for all that despite millennia of fire resilience, the sequoia are vulnerable like no other time in recorded history. The public agencies that own and manage 99% of sequoia groves, they know what needs to be done to protect the monarchs that remain, and they need our help to get it done because these ancient giants are so globally rare as to naturally grow on only 40,000 acres of California's Sierra Nevada mountains. And because a shocking percentage of those remaining monarchs have been killed in just the last 5 years alone, we have got to act. Our centennial vision also calls out the need to protect the remaining old growth giant sequoia and restore sequoia groves through fuels management and prescribed burns to enhance ecosystem function. To do so, we have to do a few things. First, we have to sound the alarm and build public awareness of this challenge, of this crisis, as we're doing here today and through our outreach, like to the New York Times for the article that came out today and several other media articles that have highlighted the mortality in the giant sequoia. And we have to coordinate with public agencies who own and manage the forest to prioritize fuels management on the groves that remain and that are most at risk. Third, we have to advocate for funding and workforce capacity to put people to work thinning the forests and managing prescribed burns in and around the remaining groves to get them ready for the fires that we know are coming. We need to get to work on the ground, leading by example on league-held land to reduce the fuel loads and bring back healthy fire into these groves. And again, we need to dramatically accelerate the pace and scale of our conservation and restoration work in both forests. We will need all of your help to get it done. So thank you to Kristen for your expertise and your excellent presentation, and to all of you for your interest in modern fires in ancient forests, and for all that you do to support the work of Save the Redwoods League. Thank you, everybody.